Bismillahirrahmanirrahim. Okay, so in the last class, we were doing writing names and then writing formulae of different compounds, okay? And we dealt with two types of ionic compounds, the binary type 1 ionic compounds, and then I had the polyatomic, and then we also had the type 2. Where can I see all the participants? I cannot see them. Yeah, I have to close this maybe. Yes, okay. Okay, so there was one point that I did not mention due to lack of time, and so I thought I would mention in the next class. And there were a few questions in the exercise that I assigned to you guys, and that was questions like this. Where did those questions go? Here, like for example, this ferrous iodide, right? And I mentioned here not explained yet. So I want to explain this part today. Okay, now this is a list of transition elements, transition metals. Okay, metals are those elements that give away an electron in reactions, and so their ions are positively charged. Now their ions can have more than one charge, right? For example, copper here can have +1, which is when it has lost only one electron, and copper 2 plus when it loses 2 electrons, right? Now in olden days, and even today, but it is less common now, but still in some books you will find these names, so I don't want you to be confused. So instead of writing these Roman numerals in brackets to indicate what ion they are talking about, they sometimes use these suffixes, OUS and IC. Okay, sometimes they use these suffixes, OUS and IC. Don't get confused. It just means that of the two ions that this transition metal has, OUS represents the ion with the lesser charge, and IC is the name for the ion which has a greater charge. Okay, I'm going to repeat this. Okay, so for transition metals, in olden days, they did not used to use these Roman numerals in brackets to indicate which ion they are talking about. Instead, they use these suffixes, and they use their old names, Latin names. Okay, most of these scientific terms have been derived from Latin language. Okay, so Cupar from copper. Okay, and then the suffix OUS represents the ion with the lesser charge, and the suffix IC represents the ion with the greater charge. For example, cobalt. Now, cobalt is also a transition metal, and its ion can have a charge of 2 plus or 3 plus. Okay, so now we use cobalt 2 and cobalt 3, but in olden days, they would use cobaltus and cobaltic. Okay, so don't get confused. If you know the two charges, you know US is the smaller of the two charge, which is 2 plus, and cobaltic is the greater of the two charge. Okay, so now the old name for lead was plumb something. Okay, again, this is from Latin, and so plumbus, plumbic. Okay, the old name for tin was stan, OUS, smaller charge, 2 plus. Stannic has a greater charge, which is 4 plus. This is 4 plus. Okay, and then again, mercurus, and mercuric. Okay, and then so on and so forth. Of these two, the ones that we are still using is iron. We're still using iron, and I cannot see iron in this list. That's amazing. How did I miss iron in this? Oh, here I have at the top. Okay, good. So iron is the one that is used still now. You will see these. You will come across these terms even today. Ferrous oxide, ferrous iodide. So this was ferrous iodide. So by OUS, I know that now, okay, the two ions that we are talking about here is iron 2 plus and iron 3 plus. So iron 2 plus and iron 3 plus. US means a smaller one. So you have to remember this. OUS, smaller one. IC, bigger one. Okay, you got to remember this. By the way, this is not that common, but yes, you do sometimes come across this. Okay, so OUS, that means I'm talking about the smaller one, the smaller charge. Okay, so this is iron 2 iodide. Okay, so once I know that, writing the formula is easy. So I will write down the symbol for iron, Fe. Iodide symbol is I. Okay, and remember this is +2 and this is -1. Why is this -1? Because it is in the 7th group, remember? 7th group has -1, or periodic table. If you, so iodine is here, okay, in the 7th group, so it has -1 charge. So -1 charge, so this charge would go here and this charge would come here. And so I have, the formula would be FeI2, okay? This could be written as cobaltic selenide. This could be written as cobaltic because we are talking about 3, the larger charge, right? Okay, so this is what I wanted to mention. So that's that. That was all, okay? And in the exercise that I gave you, there was another question which had this problem, and then there were people who were asking me, and I said just leave it because I had not explained you by that time. Where did it go? I cannot see it now. Okay, so but I think you got the point. Yes, this one, cupric nitride. Let's do this. Cupric nitride. So again, cupric means copper with the greater charge. Ic, it has suffix ic, that means it is the cation with the greater charge. So this is copper 2+. Okay, so I would write down the symbol Cu, okay, and then nitride. Ide is telling me that there are only 2 types of elements in this compound. So nitrogen is my other element, and so this is +3, and nitrogen is what? Nitrogen is in the 5th group. Nitrogen in the periodic table is in the 5th group, and it has a charge of -3. Okay, so -3. Okay, so are these balanced? Are these electrically balanced, +3 and -3? Yeah, they are. Okay, they are electrically balanced, so I don't need to add, or I don't need to add anything. So they are fine as they are. CuN, that's the formula. Okay, simple. Okay, now so we are done with the naming and writing the formulae of ionic compounds. Now let's today talk about covalent compounds. Let's move on to the covalent compounds. Now covalent compounds, what are covalent compounds? Which share their electrons. I hope everybody knows this by now, that covalent compounds are the compounds made by atoms in which both the atoms are trying to gain electrons, and hence they end up sharing instead of one giving and the other receiving, right? Now what are this is simple. Naming and writing the formula of covalent compounds is not like ionic compound. This is easy. You don't have to look at the charges or anything. This is easy. How do we do it? Let's see. So we will again discuss simple compounds first, which are made up of only 2 elements, 2 types of elements, right? So we have one element and this is the other element. So we will first of all, the first step would be go ahead and write down their names. And again, if the compound is made up of only 2 types of elements, the suffix would be "ide." That rule exists even with covalent compounds. If you have suffix "ide," that means only 2 types of elements are making that compound or making that molecule. And in case of covalent compounds, we can use the word molecule. Why? Because they are sharing their electrons and they are forming the smallest particle, which is called a molecule. So we can simply call them molecules. In ionic compounds, we were calling them ions. Okay, so one is nitrogen. Okay, one is nitrogen. The other is oxide. But the only thing is, once you write down the names of the 2 elements, there are prefixes. Prefixes meaning what you write before a word. What you write, prefix means what a group of letters that you write before a name, right? Now, this prefix will depend upon these numerals, these names, depending upon how many atoms there are of each element in the molecule. Okay, so this is the list of prefix. It is very helpful to jot it down, to learn it. It's not that hard. And you know, you must be knowing a few of them already. 1 mono, 2 di, 3 tri, 4 tetra, 5 penta, 6 hexa, 7 hepta, 8 octa, 9 nona, 10 deca. Okay, so remember, you never write mono before the first element's name. Remember this. Do not use mono on the first element. This is the list of rules. Okay, I can share this in the group. You will follow these rules when you will name covalent compounds. These are the rules for naming covalent compounds. Do not use mono on the first element. Okay, so mono is that mono. When do we use mono? When there is only one atom of that element. So what about this example? How many nitrogen atoms do we have? How many nitrogen atoms do we have? Sidra, can you please tell me? 2. So which prefix should I use?
Di.
Di. Okay, let me use di. Di nitrogen. How many oxides?
Tri. There are 3, so we're gonna use tri.
Tri. So prefix is tri. So my answer is dinitrogen trioxide. Simple. That's the name. That's the name of this compound. Dinitrogen trioxide. Simple. Okay, let's do this. Let's do this. I will do 2, and then one by one, I will ask you guys to name the covalent compounds. Okay? So let me do this other one as well. So this is phosphorus. Okay, you must be knowing this by now. And if you don't know, it's okay. Keep the periodic table with you, refer to it. P is for phosphorus. So I will go ahead and write down the name phosphorus. Only 2 elements, only 2 types of elements. So my last name will end in sulfide. Okay, by the way, sulfide can be written both ways. Okay, both spellings are correct. Either you write F or PH, same thing. This F is American, this PH is British. So no big deal, you can use any, okay? Now, what prefix will you use? What prefix will you use? Again, depending upon the number of atoms in each molecule. So Sidra, help me out. Phosphorus, how many atoms? Tetra, because there are 4, okay? So I will use tetra phosphorus, and then how many sulfide?
10, so deca.
Decasulfide. So tetraphosphorus decasulfide, that is the final name for this compound. See, this is so easy. Okay, there is no big hi-fi rocket science here. But you know, when you read this for the first time, you get scared. Oh my God, that's a very complicated name. What sort of a name is that? Tetraphosphorus decasulfide, never heard of that before. But this is no big deal. This is just this molecule. You just follow these rules. You should know these prefixes. Okay, you should know. And these rules are also simple. Okay, for the first element, start with the element name, simple. For the second element, end with the ide name. For the second element, end with the ide name. Use prefixes to show how many atoms of each type there are. Do not use mono on the first element. Okay, simple. Okay, let's move on. I'm admitting. Okay, Afan Kamran. Afan Kamran, can you please unmute yourself and talk to me? Afan? Unmute yourself. Okay, you don't have the mic option activated, and the thing is that you are not here with your Zoom ID. Please leave and re-enter with your Zoom ID.
Teacher, I can't hear you. Teacher, you're muted.
Teacher, you're muted.
Oh, sorry. Okay. Okay, so can you help me, Fatma? Can you write this name?
Yeah, teacher.
Okay.
Here's
Isn't
the
this
carbon
easy? Okay, carbon.
and fluoride.
Very good. Fluoride. Okay. And then the prefixes. So prefixes are easy, right? 1 mono, 2 di, 3 tri, 4 tetra, 5 penta, 6 hexa, 7 hepta, 8 octa, 9 nona, and 10 deca. Let's see if you remember. And we do not write mono here, right?
Yes.
Okay, so what should I write here?
Tetra.
Tetra, right, tetra. So simple. So this is carbon tetrafluoride, because we won't write mono with in front of the first element name. Okay, Fatma?
Yes, teacher.
Okay, good job. Okay. So yes, we have to write mono in front of the second element's name, but not in front of the first one. Yes, Saeed?
Yes, teacher.
Yes. Can we name this?
Okay, teacher.
Yes.
P is I have the periodic table. P
Okay.
is
Yes.
wait.
Fifth group. Fifth group. Look at the fifth group. Phosphorus. Okay.
Yeah. Phosphorus.
Okay. Phosphorus. Okay. It's okay. You know, with practice, you will remember. You will learn. No need to ratify. With practice, just keep doing lots and lots of practice.
Okay.
Okay. Phosphorus, and then so what should be
And then the next one is chlorine. I know this.
Chlorine.
Chloride.
Chloride. Why do we write "ide"?
Because there's two elements.
Right, because this is a suffix we use when there are only two elements. Very good. Okay. Now, what should I do?
Chloride, it's pentachloride.
Very good. Perfect. You guys are good. And so should I write mono here?
No.
No.
Or on the first element.
Very good. So this is my answer. Phosphorus pentachloride.
Okay.
Phosphorus pentachloride. Okay. Okay. Who's going to do this? Do you know that even, let me tell you, even 10th graders won't be able to name these. Trust me. You know, you write these formulae in front of them, ask them to name them, they won't be able to do it. Not because there's anything wrong with them. Definitely not. They're smart people. But the thing is, they were never taught. That's the problem. Okay. By the way, this is needed in IGCSE, and it is specifically asked in SATs. Okay, so this is very beneficial. Okay, Sabiha.
Teacher?
Yes.
Teacher, I'm sorry to interrupt, but in the question you did just now,
Yes.
what will we do with the
Yes.
like you wrote fluorus pentachloride? What about the L?
Which L? This L?
Yes.
This is part of chlorine symbol, Sabiha. Are you Sabiha?
No, teacher, I'm Hania.
Okay, Hania. Yes. Okay. So this is the symbol for chlorine. This is
Okay.
Cl is a symbol for chlorine. This is one atom. This is one element. Okay. If you just write C, that's carbon. That's not chlorine. If you just write C alone, that is carbon.
Okay, teacher.
Did you understand?
Yes, teacher.
Okay. Now do this with me, Hania. Do
Okay,
this.
teacher.
Yes.
Teacher, it's chlorine,
Okay. Very good.
chlorine and oxygen.
So should I write oxygen?
Teacher, you're supposed to write chlorine dioxygen.
Dioxygen. Okay. Dioxygen. Okay. Why di? Because there are two chlorine.
Yes, teacher.
Beta. Okay, first just tell me, what should I write here? Oxygen or oxide? How should I write the name of this other element? Because that's the first step. First, you write the names of the elements. So chlorine, you told me chlorine, so I wrote it down. What about this other element? What should I write here?
Oxide.
Oxide. Why? Because we use the suffix "ide" whenever a substance is made up of only two elements. Now, when a substance is made up of more than two elements, we will deal with those substances, with those compounds later. Okay? Okay. Now, after we have written these two names of the two elements, now we have to go ahead and write their prefixes according to the number of atoms there are in the molecule. So what should be the prefix here? What is the prefix for 7? Do you remember?
Yes, teacher. Hepta.
Hepta. Very good. So I will write hepta. So prefix will be written before the name of the element depending upon the number of types of that element. So because there are 7 oxygen atoms, I will write hepta before oxide. So what should I write before chlorine? Now, if there was only one chlorine, I would not have written mono, because we don't write mono before the before the name of the first element. But this is 2 atoms, but there are 2 atoms. So what should I write here? What's
Di.
Di. So dichlorine heptaoxide, that's the name. Okay?
Teacher, I have a question.
Yes?
Teacher, we will not write
Did you raise your
chloride
hand?
there.
Yeah, it's okay. Okay, go ahead. Ask me. What?
Miss, why here we didn't write chlorine or chloride?
Okay, that's a good question. Why didn't we write "ide" here? "Ide" always comes at the end of the name, not in the middle, not in the beginning. Okay?
Okay,
"Ide."
thank you.
Yes, "ide" will come at the end of the whole name, at the end of the second element's name. Remember this, Durre? "Ide" will come as a suffix at the end of the second element's name. If now in this case, chlorine is the first element. If chlorine was the second element, then yes, you would have chloride written here. But because this is the first element, we just simply write down the name of the first element without any suffix. That's a very good question. Okay, so you can do the rest, right? Should I do more practice for writing covalent? Okay, okay. Because then I was thinking that we should move on to the balancing of equations. Okay.
Can I solve this question?
Yes. Yes, Aisha?
Okay, teacher, I'm just telling.
Teacher, this is very easy. I think we should move on.
Phosphorus, oxygen,
I cannot hear you, Aisha. Can you please just speak a little loudly?
phosphorus,
Okay,
oxygen.
Oh, you're helping me with this? Okay, please do not unmute yourself like that. First, you have to raise your hand, because there are so many students who had raised their hands before you.
I'm really sorry.
It's okay, it's okay. Now, okay, go ahead and do it. So phosphorus and then oxide, right? So what should be the prefix?
Tetra
Very good, tetra.
and
What's
hepta.
the prefix? Sorry. Hepta?
Hexa.
Hexa. Hexa is the prefix for 6. So tetraphosphorus hexoxide.
Yeah.
What? Okay. Okay, so the rest of the molecules you can do on your own. So let me move on with the balancing of equation. Okay, these are all the molecules. I'll post them in the group. Go ahead and name them. Okay. Now, a few examples of how to write the formulae knowing the name. So I gave you the name and I gave you the formula and you named it, right? Now let's do the other way around. You have the name and now try to write down its formula. Simple, same rules, just go the opposite way. Okay. Now if you see if you see the name of the first element without any mono, so that means, or without any prefix, that means this is only one. Okay, I got it wrong. So if you see the name of the first element without any prefix, that means that element is only one atom in the molecule. So I will go ahead and write down the symbol of sulfur, which is S, and then oxide. Oxide means there is oxygen. So I will write down oxygen, okay? And how many oxygen? This prefix will tell me how many oxygen. Tri. So that means there are 3 oxygen atoms. There are 3 oxygen atoms. So the formula would become SO3. SO3, okay? Let's do this. So Sadra, can you help me? So the 2 elements are nitrogen and oxygen.
So a dinitrogen, so you'll write N.
So first, let me write down the symbols of the 2 elements, N, and this is oxygen, so O. Now,
so because it's written di, so it'll be N2.
N2. And how many oxygens?
Pent is
5, right? 5. So N2O5. Okay. Now, do this with me, Taha. Yes, Taha?
Yes, teacher.
Yes. Can we write its formula? The formula of this compound? Okay. So this is easy. You don't have to look at the periodic table. I mean, if you don't know the symbols, then you will have to look. Otherwise, not for the charges. Okay. Okay. Yes, Taha, I'm waiting. S. Selenium. Selenium is this, Se.
Yes, teacher. So SE.
Okay. So what is the other element?
Teacher, it is BR.
Right, Br. Yes. And how many selenium?
Teacher, only 1.
Only 1 because there is no prefix. Okay. What about how many bromine?
4.
4. So this is the formula, SeBr4. Okay, Jazakallah khairan. Okay. Now let me ask Javeria. Yes, Javeria?
Yes.
Yes.
Sulfur sign is S.
Right. Sign, symbol. Okay.
Symbol. And
Yes.
bromine symbol is Br.
Very good. How many sulfur?
Only 1 because there's no prefix.
Right. How many bromine?
6.
6. Very good. So that's the formula. Okay. Okay.
Miss,
Yes.
above you did example dinitrogen pentoxides.
Yes.
Right?
Yes.
Why didn't you write pentaoxide?
Very good. Yes. So yes. So if you have A and O or double O together, like, yeah, this is also a rule, pentaoxide, right? So when you have AO coming together, you just omit it and write simple O. That's it. Pentoxide. Okay, that's another rule. So if you have AO coming together or 2 O's coming together, for example, monoxide. Okay, if you have these 2 O's coming together, you cancel them and you replace them by just single O, monoxide, carbon monoxide. Okay. Okay, so the rest of the questions I think you can do. Okay, I will share this in the group. Go ahead and do them. This is easy. Okay, covalent compounds are easy. Okay, let's start with balancing equations. Okay, I will teach you the basics of balancing equations. And I'm muting everybody because I don't want anybody to disturb me in the middle of my explanation. Okay, so let's try to learn how to balance equations. First of all, what is an equation? An equation tries to summarize a chemical reaction in one sentence. Okay, in one sentence. For example, this is a reaction. Hydrogen gas reacting with chlorine gas combine, hydrogen gas and chlorine gas combine to make hydrochloric acid. Okay, now, well, by the way, we will also do how to name acids. That reminds me, just a little, 5 minutes, 10 minutes, and you will learn how to write the formulae for acids. Okay, so hydrogen gas combined with chlorine gas to make hydrochloric acid. So this is a word equation. Why? Because we have written down the names of each reactants and the product. So when you write the whole name of the substance or of a compound, that's called a word equation. Okay, reactants are substances which react together or which combine or whatever, they react together, and product is what you get when they combine. Okay, product is what you get. So products are on the right hand side of the arrow. Okay, so the chemical reactions are written in this way. So the substances that react, they are written on the left hand side of the arrow, and what they combine to make the product, that comes on the right hand side of the arrow. Okay, this is called a word equation. Now, chemical equation is when we replace these words with their chemical symbols using the symbols given in the periodic table. For example, but for this, you have to know how do they exist at room temperature, how do they exist normally. For example, hydrogen gas exists as this molecule, meaning that in one molecule, 2 hydrogen atoms are sharing electrons. That's how they exist. That's how the hydrogen gas exists. That's the smallest particle of a hydrogen gas. Okay, chlorine, again, similarly, also exists as a diatomic molecule. So this is an element because you don't have any other type of element in here. So both the atoms are chlorine and both the atoms are sharing their outermost electron with each other. So there are covalent bonds here, okay, because both of these atoms are trying to gain an atom, and so they are sharing, right? They combine together to form hydrogen chloride or hydrochloric acid, okay? Now, I wanna show this in the form of, I wanna show you. Yeah, we usually use chemical equations, Sidra. Sidra is asking which equation do we most commonly use. So now we have hydrogen molecules, we have chlorine molecules here. Okay, so for example, we have a couple of hydrogen molecules, we have a couple of chlorine molecules, and we have a couple of hydrogen chloride molecules, and all of these are sharing electrons, and these are covalent molecules. This is a compound. Okay, these are molecules and these are elements because there's same type of atom, but these atoms are different types together. Different types of atoms are making a molecule, so this is a compound. Okay, now the thing is that I want to know how many atoms of these are required to make this product. Simplest, what is the smallest, simplest number of these reactant molecules to make the smallest, simplest product? Smallest, simplest, yeah, you know, the substance that we are trying to get, right? So let me start with 1 molecule each. Okay, let me start with 1 molecule each. Now remember, I cannot separate them. I cannot separate them. Okay, Remember this, I cannot change these small numbers here, which are written on the right lower corner. I cannot change them. Never ever change them while balancing equations. Because if you change them, you are changing the molecule. So you have changed the whole reaction. The whole equation would get wrong. Never ever change these subscripts. And you should know what in what form does a substance exist. Some exist as simple atoms, some exist as diatomic molecules. So you should know that. Okay, you will study about them, about the substances, and you will learn. And so you will write their formulae accordingly. So we know that hydrogen exists as a diatomic molecule, chlorine exists as a diatomic molecule, and this is hydrogen chloride molecule. Okay, now what does a balanced equation mean? What does a balanced equation mean? Balanced equation means, balanced equation is the one that has the same number of each type of atom on both sides of the arrow. Same number of each type of atom. Now let's see if this equation is balanced, starting with one molecule each. There are two hydrogen atoms on the left-hand side of the arrow, but only one hydrogen atom on the right-hand side. There are two chlorine atoms on the left-hand side of the arrow, but only one chlorine atom on the right side of the arrow. So is this equation balanced, Sidra? No. Now we cannot decrease. We cannot take out an atom. Don't just take out an atom and say now, we have one on both the sides, or take one chlorine out from here and say that, it's balanced now. We can only add, and remember, addition is also of the whole molecule. For example, you cannot just go ahead and add one hydrogen atom. You cannot just add one hydrogen atom. Okay, I cannot just add one more hydrogen atom, or I cannot just add one hydrogen atom here. I will have to play with these molecules. It's like a puzzle. Okay, it's like a puzzle. What happened to my molecules here? Okay, so I will have to play with these molecules in such a way that I should get same number of each type of atom. Let's do this together. Okay, so I will have to add whole molecule. I cannot just add or subtract single atoms. I cannot do that because these substances don't exist as single atoms. Okay, now I have two hydrogens and I have two chlorines, right? And I have only one hydrogen and one chloride. So what I will do, I know there are more here and there are less here, two here and one here. Two hydrogens, one hydrogen, two chlorine, one chlorine. I will add one more molecule of hydrogen chloride. I will add one more hydrogen molecule of hydrogen chloride and then see, then check. Is it balanced now? Two hydrogen atoms here, two hydrogen atoms here. Two chlorine atoms here, two chlorine atoms here. So now this equation is balanced. Now, how will I write this change? How will I write this change? There are two molecules of hydrogen chloride on the right-hand side. Okay. Never write the two here. Okay, never. You cannot add or change these small subscripts. Okay, I repeat myself. You cannot change these small numbers on the right hand corner. Okay, right lower corner. You can neither add nor subtract. You cannot do anything to it. What you have to do is, what you are allowed to do is play with these numbers, the numbers which are written on the left hand side of the whole formula. You can only play with these numbers. You're only allowed to play with these numbers. Why? Because this number represents the number of molecules. So you can add the number of molecules, okay? You cannot change the molecule because when you change these numbers, you are changing the whole molecule. So that will change the whole reaction. That will be wrong. Okay, so there are two of hydrogen chloride. There are two of hydrogen chloride. So I will write 2 here. Let me write with a red marker. 2 here. That means there are 2 of hydrogen chloride molecules. Do you understand? These numbers give you the number of molecules. For example, if I had 2 hydrogen, I should have written 2 here if there were 2. Okay, but it's only 1. And remember, a balanced equation is always the simplest and the smallest numbers. Simplest and the smallest possible numbers. Okay? Okay. So if you have understood this, let's do another equation. Is there any question? Please ask. Is there any question? I allow you to unmute yourself and ask. Yes, this small number represents the number of atoms within one molecule. This small number on the right lower corner represents the number of atoms within the molecule. If there is any question, I allow you to unmute yourself and ask. Otherwise, I will move on to another example.
Teacher,
Okay. If more than one has question, then everybody lower your hand. Everybody lower your hand, and only the ones that have questions will raise their hand, and I will unmute them. Okay, Taha. Yes, Taha. Taha, where did you go? Okay, Hamid.
Teacher,
Yes.
what if there are 4 hydrogens in this side?
Yes, we will do many examples, Taha. We will do a lot of examples. Remember, the equation will depend upon the reaction that takes place. Okay, you are only allowed to add these numbers. Okay, that's all. Okay, I mean, you know, then we will learn different examples. Okay. Okay, Saeed.
Teacher?
Yes. Yes, Saeed.
Yes, teacher.
Yes.
Why is it necessary to be simplest and the most least atoms?
Yeah, because you know, we want to deal with the simplest and the smallest ratio, because you know, otherwise you can go as high as possible. I mean, you can go as high as possible, but you know, for our calculations, for our purpose, we want to know the smallest, simplest ratio, because that makes things simpler. That makes studying
this is gonna be wrong if it's not balanced, right?
What? This is balanced. Now it's balanced. So we have one hydrogen molecule, one. We don't write one. So I did not write one. We don't write one. Okay. When we don't have any number, it means there's one.
So will we write the 2 before the
hydrogen chloride?
Small or big?
What do you mean? Small or big?
Like H and then the 2 is small.
Yeah. So this 2 means there are 2 hydrogen atoms within this molecule. So there's only one molecule. So remember, this is telling you the number of molecule. Okay, this is telling you the number of molecule, and this is telling you the number of atoms within a molecule. Number of atom in the molecule. So how many molecule do you have? 1, right? There's only 1, right?
Yes.
But how many hydrogen atoms in the molecule?
2.
2. So that's why you have 2, 1 here and 2 here. 2 means the number of atom in the molecule, and this means the number of molecule.
Okay. So the number of molecule is itself, and the atom is which is inside it.
Right. Yes.
Okay.
Did you understand? Okay. Durre, yes. Oh, what happened?
So ma'am,
Yes.
how will we write the balanced equation? Like answer, what would be our answer for that?
Yeah, this is the answer. So you can write it like this: hydrogen plus chlorine giving you hydrogen chloride. This is the final equation.
Thank you.
Okay.
I understood.
Okay, Zed.
Teacher, can any 2 atoms be together as a molecule?
Yes, that's what they are doing here. The 2 atoms are together as a molecule.
Teacher, can I ask another question?
Yes.
Will it be wrong if we will not write in the simplest form in the
Yes.
text or something?
Yes, it would be wrong if you don't write in the simplest form. Yes.
Okay.
Why? Because you see, the ratio is 1:1:2. So, you know, like if you write 2, 2, and then 4, well, that will also be balanced. If I write this, look at this. If I write 2 hydrogen, 2 chlorine, and 4 HCl, sorry, 4 HCl. So this is also balanced. 4 hydrogen atoms here, 4 hydrogen atoms here, 4 chlorines here, 2 2s are 4, 2 2s are 4, 4 chlorine. This is also balanced, but this is unnecessary. This is unnecessarily bigger. These are bigger numbers. There's no point in this. We don't write like this. We write in the simplest form. We write in the simplest form.
So there is no point of writing it.
Yes,
like that.
yes, there's no point. Okay, let's move on. Okay, let's move on. Yes, Hamid, is there any question? Yes. I'm trying to unmute you, but you're not getting unmuted. Okay, let's move on to the next equation. And then I will give you practice equations and you go ahead and you do them. Okay, this is my other equation. Yes, Hamid, is there any question? You're unmuted.
No, teacher, by mistake. No, teacher, by mistakenly.
Yeah, please lower your hand. Okay. So now this is another equation. Hydrogen gas combines with oxygen gas to give water. Okay. Where are my hydrogen and my, so water molecule here. Okay. And then oxygen molecules here. And then these are my hydrogen. Let's now play with them. Let's see. Okay. So now I want same number of each type of atom on both the sides. Okay, smallest, simplest, right? Now let's just start with one molecule. Okay, I'll remove these other and I will add them as are needed. Okay, as are needed. So 2 hydrogen atoms on the left hand side and 2 hydrogen atoms on the right hand side. Okay, so they are balanced. Hydrogen is balanced, but what about oxygen? 2 oxygen on the left hand side and only 1 oxygen on the right hand side. So what should I do? I can only add a molecule. That's all I can do. So I will add 1 water molecule and then see. Now are the atoms balanced? Now oxygen is 2 atoms. Oxygen are 2 on the left hand side, oxygen are 2 on the right hand side. So okay, oxygen got balanced, but now hydrogen is not balanced. There are 2 hydrogen here and 4 hydrogen here. Okay, so let me add 1 more hydrogen molecule and now see. Now are they balanced? 4 hydrogen atoms on the left hand side, 4 hydrogen atoms on the right hand side. 2 oxygen atoms on the left hand side, 2 oxygen atoms on the right hand side. Yeah, now I'm balanced. So now what should be the numbers I write? How many molecules am I using of hydrogen? Sidra, I'm using 2. So I will write 2 here. Only 1 molecule of oxygen, so no need to write 1 because we don't write 1. How many molecules of water? 2. Yes. So I will write 2 here. So this is my answer. I balance the equation. So that means 2 hydrogen molecules combine with 1 oxygen molecule to give me 2 water molecules. Okay. Is there any question? Is there any question you can ask me? Raise your hand and I will unmute you. Otherwise, we will move on. Let's move on. Okay. I cannot see any raised hand. Okay, Saad. Unmute. Yes. Yes, Saad. It takes some time to get unmuted. Yes, Saad.
Miss, how did you get 2 water?
So I added one water to see if things are getting balanced. Okay, I added and I saw if the things are getting added and getting balanced, but that was not simply balancing, and so I had to add one more hydrogen molecule. Did you see?
Okay, miss.
See? Okay, so first I started with one molecule and then I saw that I needed one more oxygen atom. So I am only allowed to add one whole molecule. I cannot just go ahead and add one more oxygen atom. I cannot do that. I am only allowed to add molecules. So I added this one whole molecule, but then I ended up with 4 hydrogen atoms. So then I added one more hydrogen molecule, and so now I have 4 hydrogen atoms on both sides and 2 oxygen atoms on both sides. Is that clear?
Okay, miss.
Okay, we'll do more practice, okay?
Miss, I also have one more question.
Yes.
What is the prefix 9 called?
Prefix 9 is nona, N-O-N-A. I will share that list in the group. Okay, don't worry. Okay. Okay, let's move on to the next equation. Okay, again, we have nitrogen and hydrogen gas combined to give ammonia. So this is hydrogen. Okay, wait. And then we have nitrogen. Okay, go ahead and unmute, Javeria. Okay, and it's giving me ammonia. Ammonia exists this way. Now, sometimes we have common names for substances. Like, for example, ammonia is a common name. Okay, it does not follow any rule. Okay, like, for example, water is a common name. Water is a common daily language name. We don't, where did the nitrogen go? Here, nitrogens are here. Nitrogens are here. Okay. So this is nitrogen molecules reacting with hydrogen molecules to give us ammonia, okay? Now let's see. Let's start with one molecule each. 2 nitrogen atoms on the left-hand side, 1 nitrogen here, okay? So let's start with trying to balance nitrogen. I'm only allowed to add a molecule. So I have to add another ammonia so that I can have 2 nitrogen atoms. But now I have total of how many? So the nitrogen atoms are balanced. There are 2 nitrogen atoms on the left-hand side, 2 nitrogen atoms on the right-hand side. But what about the hydrogen atoms? On the right-hand side, I have 6 of them. 1, 2, 3, 4, 5, 6, and I have only 2. So 2 3s are 6. What if I have 3 molecules of hydrogen? So now am I balanced? 2 nitrogen atoms on the left-hand side, 2 nitrogen on the right-hand side, 6 hydrogen atoms on the left-hand side, 6 hydrogen atoms on the right-hand side. Now, let me write down the number of molecules as coefficients. Remember, these numbers that I am writing on the left-hand side of this whole thing, of the whole symbol, these are called coefficients. Coefficients. These are called coefficients. So we are only allowed to change the coefficients, and these are called subscripts. These are called subscripts. We are not allowed to change the subscripts. We cannot add or remove any subscripts. Okay, so how many molecules? 3. So I will write down 3 here. How many molecules of ammonia? 2. So I will write down 2 here. So this is balanced. Okay, this is a balanced equation. So the reason why I made these cutouts is for you to be able to differentiate between the atoms and the whole molecule. Okay, I want you to appreciate the fact that we are only allowed to add a molecule, and that is why we are only allowed to change the coefficients. We cannot separate these. We cannot separate these. Okay, I cannot do that. If I do that, then that will be completely different reaction. Okay, because the particle is now something else. It's a different substance. different chemical and physical properties. So that would make the whole equation and reaction wrong. Okay, now let's do a few more examples. Okay, and then there are Hajj holidays coming up. So you go ahead and do practice during your Hajj holidays. Okay, let's start with this. Okay, why is it important that the number of atoms of each type of element should be the same on both the sides? Is because atoms don't just vanish into thin air, or they don't just jump in out of nowhere, okay? Whatever number of atoms you started with, you're going to end up with the same number of atoms, because atoms did not go anywhere, okay? The only thing is that they rearrange themselves, okay? They rearrange themselves in a different form, but the total number of atoms stays the same during a reaction, okay? Now let's do a few simple, straightforward questions. Let's do a simple, straightforward questions, okay? And then, okay, I can see a few raised hands. Okay, Fatma?
Yes, teacher.
Yes, is there a question?
No.
Okay, then why was your hand raised? Okay, Javeria? If you
I
don't
wanted to
have a
answer.
question- Yes?
I wanted to answer the question.
Okay, please lower your hand. If you don't have a question, please lower your hands. Okay, Zed, do you want to ask a question?
Ma'am, is there a molecule that has more than 4 atoms?
Yes, yes, they are. Yes, yes,
Oh.
okay. Yes, we will as you will study chemistry, you will come across a lot of different types of molecules and atoms. Okay, now this is a simple equation. Let's try to balance it, okay? So this balancing of equation I showed you with the cutouts and, you know, adding molecules and everything. Now you cannot have cutouts all the time, right? You won't have cutouts in your exams. So you should be able to balance them without the cutouts, okay? So let's see how to do this. Now this is xenon. Xenon is an element in the periodic table. And where is it? I don't know where it is, but wherever it is, it's a noble gas. Oh, it's a noble gas. So this is a very rare reaction. This is a very rare reaction. So, okay, xenon is reacting with fluorine to give xenon fluoride. Okay, these are the formulae. Why have I made these circles? In order to show you that we cannot change them. Okay, we cannot change them. We can only change this. Okay, so what I do is I make a list of the elements. This is how you will start balancing. This is how you will start balancing for now. Once you get expert in it, then you don't need to make list. You can just directly balance. Okay, but because you are a beginner, you're doing it for the first time, you will make a list. Okay, at least for my practice. I mean, for when you are practicing my worksheets. So xenon, I wrote down the symbol, and then fluorine. Okay, and then xenon and fluorine. Now this list is so that we know how many atoms of each type. Now because there is nothing here, so there is only one. So I will write down 1. And then there is no subscript, no coefficient. That means there is only 1 here on the right hand side too. But what about fluorine atom? How many do I have here? Okay, and remember we are balancing the number of atoms. Okay, now I can see the subscript 2, so that means there are 2 fluorine atoms here, but there are 6 here. The subscript is telling me there are 6 of fluorine atoms. That means fluorine is not balanced. Now what can I do to balance fluorine? Okay, this is L.
Teacher?
Oh, there should be no L. Sorry. This is
Teacher,
just,
there was an E there.
sorry?
There was an E there.
Yeah, that was a mistake. I'm sorry about that. Yes, okay. You said that the small can never change. Yeah, so it's not changing. But yes, it is telling me the number of atoms. It is telling me the number of atoms. So I will go ahead and balance it, okay, without changing these. I cannot change these. Without changing these, I have to balance them. Okay, So if I multiply this by 3, I will get 6, right? If I can multiply this by 3, I can get 6. So if I can have 3 of these fluorine atoms, I can have total of 6 fluorine atoms. If I can have 3 of these fluorine molecules, I can have total of 6 fluorine atoms. Okay, like this. So each is fluorine. So how many? 1, 2, 3, 4, 5, 6. And so there are 6 here as well. Okay, so then my fluorine would be balanced. So that so I have 1 xenon on the left hand side, 1 xenon on the right hand side, 6 fluorine atoms on the left hand side, and 6 fluorine atoms on the right hand side. So now I'm balanced. Okay, so xenon reacting with 3 fluorine molecules to give xenon fluoride. Okay, now this sulfur. Now somebody asked me that can we have a molecule with more than 4 atoms? Yes, so here you go. In one molecule there are 8 sulfur atoms, 8. Okay, 8, and then there's 1 here. Okay, go. Okay, and there are 2, and there are 2 oxygen atoms here. So I can see that the oxygen atoms are balanced. There are 2 on both the sides, but sulfur is not balanced. So what should I do? I can multiply this by 8. But if I do that, if I write 8 here, what will happen? 8 2s are 16. So I'm also changing oxygen. So this would become 16. But I have only 2 here. So now sulfur are balanced, but now oxygen is not balanced. But then can I multiply this by 8 as well to get 16? Can I do that? And so then that would give me 16 oxygen atoms on both the sides. Yeah, so now I'm balanced. Okay, so my final equation would be sulfur reacting with 8 oxygen molecules to give 8 molecules of sulfur dioxide. That will be my final equation, balanced equation. Okay, now Sidra wants to do this one, and then you can do 2 more, and then after that I will end the meeting. I know I will take a few extra minutes. Okay,
Teacher, can I please ask a question about the
yes,
about,
sure, yes, okay,
why
yes.
did you change the oxygen?
This,
No, on the right side when there were 8 sulfur,
yes,
why did you change the oxygen? And why did you say
yes, okay, that's a good question. See, when I added 8 here as a coefficient, what does this mean? This means that there are 8 sulfur dioxide molecules. Okay, now in
Yes.
each molecule, in one molecule there are 2 oxygen atoms. So if I have 8 of them, I have total of 16 oxygen atoms. So remember, this coefficient gets multiplied, this coefficient gets multiplied by each subscript of each element. So 8 1s are 8, so there are 8 sulfur atoms, and 8 2s are 16, so there are 16 oxygen atoms. So if I add 8 here, I am basically also changing the oxygen atom number, and it's increasing from 2 to 16.
Okay.
Did you understand, Saeed?
Yes.
Remember this, the coefficient gets multiplied by each element subscript. Okay, Sidra, can you please do it real quick? Okay, and also explain how, what you're working. Explain your working.
Okay.
So write down the number of each element. There are 2 here.
So there are 2 atoms and hydrogen here and 2 atoms here.
2 atoms of hydrogen there. Okay.
And in oxygen there are 2 here, but
only 1 here.
only 1 there.
Right. So that means we need to balance the oxygen because hydrogens are already balanced. Okay.
So we're gonna add another oxygen.
Right. Multiply by 2, so you get 2. But when you do that, if you add 2 here, what happens to hydrogen? Yeah, this big, no, just cancel it and write down 4. It became 4. So now oxygen is balanced, but hydrogen.
So you're gonna add another hydrogen.
So, okay, go ahead. 2. Yes, so write 2 here because you multiplied by 2. So write down 2 here. So coefficient gets multiplied by the subscript.
So you got 4.
So now we have 4 hydrogen atoms on the left hand side, 4 hydrogen atoms on the right hand side, 2 oxygen atoms on the left hand side, and 2 oxygen atoms on the right hand side. So we are balanced. Good job. So 2 hydrogen plus oxygen giving us 2 water molecules. This is a balanced equation. Okay, who will do this? Yes, Fatima. I like it. Yes, Fatima. Once you get the hang of it, you enjoy balancing equations so much. And do you know that most of the chemistry students, they run away from balancing equation? While this is like a puzzle, you know? Okay, Fatima.
Yes, teacher.
Okay. So I made the list already for you. So you go ahead and tell me the number of each atom, of each element's atom number.
Teacher, Ag is 1.
Silver. Okay, silver is 1 on the right hand side. How many on the right hand side?
2.
2. Okay. Hydrogen. How many hydrogens on the left hand side?
2.
2. On the right hand side?
2.
2. Okay. How many sulfur on the left hand side?
1.
1. How many on the right hand side?
1.
1. So are we balanced?
No.
No. Okay.
We will multiply iron.
Silver.
Silver by 2.
Okay. So I should write 2 here?
Yeah.
Yes. So now are we balanced?
Yes.
Yes. So we are balanced. Simple. You just had to add 2 here. That's it. Okay, Saeed.
Yes.
Okay, go ahead and do the next with me.
K is potassium.
Right.
I'm pretty sure I know that.
Okay.
So there's 1 potassium atom,
Okay.
and on the right hand side there are 2 potassium atoms.
Okay.
Okay. Oxygen, there's 1. Oh, sorry, 2.
Count again.
There's 2.
2, and then this is also there. 2 plus 1, 3.
Okay, 3.
3. Okay. How
Yes.
many here?
Now here there are 4.
4. Okay.
Now H is hydrogen, and
Yes.
there's only 1 hydrogen here.
Okay. How many
And
hydrogen
on the
here?
right hand side there are 2 hydrogen atoms.
Very good.
Now the C is
Carbon.
there's only 1,
Where there is only
C.
1?
and here there are only 1 also.
1. Okay. So that means only carbon is balanced. The rest of them are not balanced. Okay.
Yes. First, let's balance potassium. So multiply.
Okay, very good. Multiplied by 2. Yes. So I will write 2 here. Yeah, where did you go, Saeed? Okay, Taha. I don't know where Saeed. Yes, can you please continue? So Saeed told me to multiply this by 2. So yeah, I wrote down 2 here. So now what happens? Now how many oxygen do I have? Come on. You don't want to do? Okay, Sariha. If you don't want to do, yeah, those students who don't want to participate, please lower your hand. Yes, Sariha, can you please now tell me, now after I added 2 here, what happens to oxygen and hydrogen?
For hydrogen, we will multiply hydrogen with 2. It will equal to 2. So hydrogen is balanced now. Now oxygen is left.
Beta, okay. Okay, so this becomes 2 because now we have 2.
Teacher, I couldn't hear you. There was a mic problem.
Yeah, okay, Sariha, let Saeed complete. Okay, then I will.
miss.
Okay,
Oxygen, I think we're gonna 3 is gonna multiply by 4.
No, you see, listen. You will first tell me that after adding this coefficient, what happens to the rest of the atoms which are with it? Okay, because they're also getting multiplied. Remember, so 2 potassium.
So they also need one more.
Yes. So now I have how many? How many do I have? 1, 2, and then 3, 4. Right?
Yes.
2 and
Yes.
1. Right? This is when you don't have a subscript. That means 1. So 2 ones are 2. So 2 here and 2 here. 4.
4.
So
this
4
is balanced
oxygen
then.
atoms and 2 hydrogen atoms. So now look at this. 2 potassium, 4 oxygen, 4 oxygen, 2 hydrogen.
Now it's balanced.
Now balanced. Good job, Saeed. I like your enthusiasm. I like it. Now let me give you some helpful tips. Some helpful tips. They they don't work all 100% of the times, but yes, most of the times these tips are helpful. Okay. Elements which are in all the compounds should be balanced last. Okay, for example, oxygen was in all the substances. Can you see? Oxygen was in potassium hydroxide, in carbon dioxide, in a carbonate in this water. Usually, not all the time, usually you should leave them for the end. Never start balancing the oxygen. I mean, never start balancing the element which is found in all the reactants and products. Okay. Also, elements which exist on their own in the elemental form should also be balanced last. For example, hydrogen is on its own, like there is no other element with it. So these should also be left for the last. Okay, and then so these are just tips. Okay, now just one more type of equation I will teach you, and then you will do the rest on your own. Okay. Now remember the polyatomic ions. Remember the polyatomic ion table that I showed you? This. And I also mentioned that they exist as one particle. They behave as one particle. So wherever they go together. Remember? So in the equation, when you see a polyatomic ion, like this is sulfate. Sulfate? Yes, this polyatomic ion. I can see that sulfate is not breaking, but sulfate is staying as it is, both in the reactant and the product. When you see something like that, you can even see carbonate like that. You can even see nitrate like that, or hydroxide like that. So when you see a polyatomic ion in both reactant and product, balance them together. Don't write their elements separately. You will get confused. Don't write sulfur and oxygen separately and balance them. Then you'll get confused. Because they behave as one, you also treat them as one. Okay? So then it'll be so easy. Then it will be very easy. But for that, remember, the polyatomic ion should be the same on both the sides. Okay? If you see that the polyatomic ion is breaking up, because sometimes they break, very rarely, but they do break. Okay, if you see the polyatomic ion breaking, then you cannot treat them as one. Then you will have to balance each atom separately, each element separately. Okay, now let's do this. Who will do this with me? Zed.
Yes, ma'am.
Yes, please. Let's do this together. It's okay. Okay. So tell me the number of atoms on each side, looking at the equation.
Okay. 1.
1.
Here is 1 on the left side and 2 on the right hand side.
Very good. Hydrogen.
2 on the left hand side.
Very good.
And 2 on the right hand side.
Very good. Now tell me how many sulfate, this whole thing. Only one. Right, only one. Okay. How many here?
3.
3. So now let's balance aluminium first.
We'll multiply 1 by 2
Yes.
Now
So then I should write 2 here.
yes.
Okay. Now hydrogen is balanced, but sulfate.
Yeah.
Sulfate,
So
there are 3 here.
1 is. So we'll multiply 1 by 3.
Very good. And so that means I should write 3 here, right?
Yes.
Right. Now when I write 3 here, what happens to hydrogen?
It multiplies by 2.
So then
It 6.
6. This becomes 6. So
Yeah.
what should I do here now, because hydrogen is not balanced? So what should I do here now?
Multiply by 3.
Multiply by 3. That means I should write 3 here.
Yeah.
Right. So now we are balanced, right?
Yes.
2 aluminium, 6 hydrogen on both the sides, and 3 sulfates on both the sides.
Yeah.
Okay. So this is how you balance the equation when you have polyatomic ion which has not changed on both the sides of the equation. Okay. For example, this is another example of polyatomic ion. Can you see polyatomic ion? You can see the hydroxide on the left hand side. You can see the hydroxide on the right hand side. So this has not changed. So I am treating it same as 1. Okay. Okay. Zaid.
Yes.
You're Zaid. Okay. Taha. Okay, Javeria.
Yes, teacher.
Yes.
Yes.
I'm
Yes,
here.
I know we are running out of time. I know we are late today, but that's okay because this is my last class before the Hajj holiday. I don't want to leave this in the middle. Okay, so this is the last equation. The rest you will do. Okay, so this is the last equation we are solving. Okay, so Javeria, please tell me the names of the number of atoms of each type of element in both the sides.
Okay. 1.
Okay,
1.
1.
Same 1. 3
Yes.
and 1.
Okay.
1 and again 1.
Okay, 1 and then 1. Okay.
1
Yes.
and 3.
3. Okay. So
Okay, first of all,
yes.
let's balance the chlorine.
Okay.
I'll multiply 1 by 3 on the right hand side. So I'll add a 3 before iron.
Iron?
Sorry, I mean sodium.
Sodium chloride. Right. Okay. NaCl. Okay. So now
Yes.
that changes.
It's a sodium. So I
Right.
multiply that with 3 as well.
Okay. So that means I should add 3 here.
And that automatically balances the hydroxide.
Yes. Yes. That automatically balances the hydroxide. So now let's check iron 1 on both sides, chlorine 3 on both sides, sodium 3 on both sides, and hydroxide 3 on both sides. Okay, so good job. Okay, so I hope you guys understood how to balance equations. And so alhamdulillah, before the Hajj holidays, we have learned how to write formulae, how to name compounds, and how to balance equations. If there's any confusion, you can ask me right now. You can even listen to the recording and then ask me privately. Yes, are these hand raised? Want to ask a question or do they want to answer? If you have to ask a question, only then raise your hand. Yes, Zana? Okay, there's no question? Okay then, okay. Then enjoy your Eid holidays. Okay? Okay, Assalamu alaikum wa rahmatullahi wa barakatuh.
Allah Hafiz.
Allah Hafiz, miss. You enjoy too.
Allah Hafiz.
Fish teacher, advance Eid Mubarak.
Yeah, Eid
Miss, Eid Mubarak.
Mubarak to all of you.
Eid Mubarak.